This is the lesson for Chapter 7, Section 7, Exponential Growth and Decay, day number 2. And so what we're doing today is we're just looking at compound interest. And so compound interest is what banks end up paying. And so when we are dealing with compound interest, it's a little more difficult than simple interest because we're compounding the after a compounding period, we add that interest to the principal, and then we calculate it again after each time that we end up doing this. And so you'll notice that the formula has more than just the rate. And so typically a simple interest problem is principal times rate times time. Now we are bringing the time and we're using that as an exponent. And also we have a number of compounding periods. So here's what we have. A stands for the balance, it says. P is the principal, which is the initial deposit. R is the annual interest rate, expressed as a decimal. And then the N is the number of compounding periods per year. And so we have some different ones that we'll see. So for instance, annually is just going to end up being equal to 1. So N would end up being 1. So maybe I'll write that down. N equals 1. Where if it's semi-annually, we'll say that N equals 2 because it happens twice a year. And then we could see quarterly, and quarterly would just be N equals 4 because it happened 4 times a year. Or we might see monthly, and monthly would just mean that we'd have N equaling 12. So those are the typical ones we're going to see. Now time is always in years, and so make sure yours is in years. Sometimes they try to trick you and they put it in 6 months, and so then you'd have to do a half of a year, 0.5 would be the number there. So let's check out the problems that we'll see. So it says find the balance. The balance is your A term, so you're just solving for A. And so let's go ahead and substitute in. So we've got our principal earnings, so it's going to be, this is our P, earning 5%, so this is R. Now you're going to change that to 0.05 though, compounded annually, so N equals 1 after 6 years, so T equals 6. And then we just substitute those numbers into the formula. So we would have A equals 8,000 multiplied by 1 plus, now it's 1 because 8,000 times 1 makes 8,000. So you're taking the initial amount, but then we're adding on the interest. So that's going to end up being 0.05 over 1. So that doesn't change anything there, the over 1 part. And then 1 times by t, which is 6 years. So when I go ahead and simplify this, it would be 8,000 times by 1.05 all to the 6th power. So you have some calculator work to do. So we'll do the 1.05 to the 6th power, and that gives me this. I get 8,000 being multiplied by 1.34, and then there's some other numbers, 0.09561. And so I'm using all those numbers because I'm just going to press times, and it just takes that answer, and then I multiply by 8,000. And that gives me my answer. And so our answer in this case is going to be 10,720.77 So I got 765. So I'm going to round that up to 77 cents. So $10,720.77. So that's the balance after those 6 years. Let's take a look at the next one. It says $2,000 principal, so that's your P value, earning 5.4, so I'm going to change that to 0.054. And then I'm going to end up compounding annually, so N equals 1 again, and T equals 4. So if I was to set it up into the formula, it would be A equals 2,000 times by, and then I've got 1 plus 0.054 over 1, because it's the number of compounding periods there, times by 1 times 5, the number of compounding periods times by the time. So I'll simplify that a little bit. So I've got 2,000, and then 1 plus 0.045, so let me fix that real quick. I'll just put it in the decimal form right now. 1.054, I should say, all to the 4th power. So we go ahead and enter the 1.054 to the 4th power, and that gives me this number. So I get 2,000 still, my initial amount, times by 1.23413, and then it continues on. So I take that answer and I multiply it by 2,000, and this is what I get. I get 2,468.268. So I gotta look at the thousandths place and see what to do to the hundredths, and this time I round up again. So $2,468.27. So you can see when the savings were good, we would like a 5%, 5.4% interest rate compounded annually for 4 years. Hey, you earned $468.27. Not too bad. So let's take a look at two other problems. Here we have $500. So that's your principal, compounded at 4%, so 0.04. Compounded quarterly. Okay, so now we have a new one. N equals 4. So they're paying us more often, and so we're recalculating the percentage, our amount every quarterly, every 3 months. And then we have T equals 10. So I'll go ahead and substitute the numbers into the formula. So I've got 500 multiplied by 1 plus 0.04, but this time I really do have to do some division. I have to divide by 4. And I'm going to take that and bring it to the 4 times 10 power. So you can see this number is going to get smaller because I'm dividing it by 4, so it's not going to be as big of a number. So let me do that. 0.04 divided by 4, because I'm paying every 3 months, and so this is going to be 1.01 now. So this was 0.01 right here, and I add the two numbers together. You see how much smaller it is than the last few problems. See, when it was annually, that number was much bigger. It was 1.34. When I multiplied it, it made a much bigger number. But this number is going to get bigger because I'm bringing it to the 40th power. And so I have to multiply this by itself 40 times. So that's why you got to have a calculator to do this. So let's go ahead and do that work. I'll raise that to the 40th power, and that gives me this. I get 1.4888, and then it continues on. And so I'm going to take that number and multiply it by 500. And so let's see what we get. Times by 500, and that gives me this, $744.43. So it's a 1 right here, but that's not big enough to round that up. So $744.43. So I want you to compare, though. You can see how this is a smaller number because we had to divide it by the number of compounding periods. But take a look at this number here. When I brought this to the 40th power, look at this size, 1.4888. So it's almost 1.5. So I'm almost doing 1.5 times the number. So that number and then half that value every single time we go ahead and pay it off. So let's take a look at the last few problems. See, when it was compounded annually, we just multiplied it, we just added it to the 1, but then we brought it to a smaller power. And notice how much smaller that number is. See, when it was 4% or 5%, it was only 1.23 we multiplied by, so not nearly as big. 1.34 at the 5%. And so you can see those percentages are bigger than the percentage we had here at 4%, but compounded quarterly made it pay off a lot more because we had more compounding periods. So we'll see that with this next one as well. So again, our principal is equal to 6,500, and our rate is 0.028. So not as big of a rate, but look at what we're compounding it by. We're compounding it monthly. So N equals 12, and we're doing it for 2 years. Now, we're not doing it for as long, so we're not going to see that number be as high, but the compounding periods are pretty good size. So let's take a look at it. 6,500 multiplied by 1 plus 0.028. Now, I need to write that as a fraction, so I'm going to put it a little higher up. 0.028 over 12. And then I bring that to the 12 times 2 power. So I do this work. So 0.028 divided by 12 gives me this number. So I get a repeating decimal here, 2.3, and then it repeats. And that's because 3 is underneath that, is a factor of 12. So I'm going to show that 3 repeating there. And actually, it's not even that. So let me go ahead and redo that real quick. It's mine was in scientific notation. Mine showed this 2.3 repeating, but then times by 10 to the negative third. So I have to move that decimal over 1, 2, 3 spaces. So I have to add 2 zeros there. So that's going to be 0.002, and then 3 repeats itself. So I'm going to go ahead and add my 1 to that. And then I'm going to take that number and bring it to the 24th power, and then times by 6,500. So let me go ahead and bring that to the 24th power, and that gives me this number. It's not nearly as big because the interest rate was smaller, and also the number of years is smaller. So it's only 1.0575, and then it kind of continues on. And I'm going to take that number and multiply it by 6,500. And so I times by 6,500, and this is what I get. I got $6,873.93, and then 0.6 of a cent. So 0.6 of a cent is going to round that up, $6,873.94. That's the value that we should end up having. So those are the types of problems that you're going to see on tonight's homework. Good luck.